Let's look at this example. Let's take, for example, this cell 1 of keyboard A and taking 21 to 40 hours. What is the observed values? What is the observed value here? Observed value is 25. Do you see that? Now to find the expected value, let's call it U1. The observed value of cell 1 is 25. Now the expected value of cell 1 will be, what is the total row of cell 1? The total row is the row. And total is what? If you don't speak loud, I will not hear. You see, this is the row. And this is the column. See what happened? So what is the total on the row? 80. Total for column. And the total. So what is this equal to? What is this equal to? 24. So the expected value will be 80 times 90 divided by 300 equals to 24. Meaning that if there was independent, we should find 24 at that point. Let's take another cell, maybe cell 6. Cell 6, if you can see the numbers associated with it. What is the observed value for cell 6? 19. What is the expected value? Total row is 120. And total column 50, 60. When we divide by 300, what do we get? So I just want you to know what to do to get the expected values. Row times column divided by total. So, as I mentioned before, hypothesis will be 80, keyboard and learning time independent. One, keyboard, learning time, not, we can say are dependent or not independent. But get used to writing the same thing, because sometimes you might say are not dependent instead of say are not independent. So are not the opposite of H1. The test value is chi-square equals to sum of observed minus expected value squared divided by expected value. So at this point, we will use calculator to compute this. You can find E and O for each of those values. But we don't need it. So let's use calculator. You have your calculator, get it? If you have your calculator, go to matrix. We enter data here for this kind of table on the matrix. How many rows do we have here? Don't count the total. How many rows? 3. How many columns? 3. Those are where we have our data. So we go to matrix and go to edit. Matrix, edit. And then you will see dimension. Maybe you have 1 times 1 if you have not used it before. Change it to 3 times 3. And then you press enter. If you have trouble, let me know. And then you will just type 25, enter, 30, enter. Where it goes, you see what position of that number is. If you are on Zoom and you have a question, just ask. We are using calculator to enter the matrix, the data on a matrix. So you go to matrix, second function inverse, and go to edit, change it to 3 times 3. Press enter, and then enter each of the 9 values in the 3 by 3 matrix that we have. If you have your data in the matrix, you can now go to start, test, and choose chi-square test. As you choose chi-square test, you will have observe A or expected B. Don't change anything, just do calculate. So if you wanted to do this manually, you will compute the observe, oh no, I'm sorry, you will compute the expected values and put in a column, observe, expected, do O minus E, and then take the square. O minus E, then take the square, divide it by E again, and add them up. And you see the chi-square, the test value. What do you have for test value? What is chi-square? And what's the p-value? 0.009? Yeah. We all have this, or something very close to that. So here, if alpha was 0.05, if alpha is 0.05, what can we say? Is p less than or greater than alpha? So we will have this chi-square is equal to 13.1. The p-value is 0.0, let's just say 0.1. And p is, if alpha equals to 0.05, p is less than alpha, so reject, it's 0. Remember that our plane is H1. So the conclusion will be at alpha equal to 0.01, there is enough evidence to reject the claim. But keyboard arrangement and learning time are independent. we reject the null hypothesis. That means we cannot say that keyboard arrangement and the time you take to learn are independent. So they are actually dependent. So the time you take to learn depends on which type of keyboard you are using, actually. That's the conclusion of this statistical test. The time you take to learn depends on the nature of the keyboard you are using. So in test of independence, H0 is the variables are independent. H1, the variables are not independent. You will have a table on a contingency table with a certain number of rows and columns. Enter it on matrix on your calculator, and then use the chi-square test to get the test value, the p-value that you compare to alpha to make a decision and a conclusion. So the next test is the test of homogeneity, which is similar. The test for homogeneity is similar to the test for independence. In the test of homogeneity, we are trying to test if the proportion of preference of a group is the same as another group. For example, Tim is doing a research project involving pet preferences among students at his college. He took random samples of 300 female and 250 male students. Each sample member responded to the survey question: if you could own only one pet, what kind would you choose? The possible responses were dog, cat, other pet, or no pet. So a male and female have the same preference of pet. So we have this table that gives us the data, the observed values. Does the same proportion of males and as females prefer each type of pet? That is our question. So the claim here will be the same proportion of males as females prefer each type of pet. Use a 1% level of significance. So to start, we want to enter these values into the calculator. How many rows do we have? How many rows? How many columns? 4. So let's get it into our matrix. We go to matrix, edit. Enter the data into your calculator. So the hypothesis here will be H0, the proportion of female and males naming each pet preferences are the same. And the H1 will be they are not the same. So you use your calculator. What is chi-square? What is chi-square here? Are you having trouble doing the test? Start, test, chi-square, and just go to calculate once on the data matrix. What do you have as chi-square? What have the also that I confirm? What is chi-square? Anybody on Zoom has chi-square? What do you have? Okay, let me check for everybody individually. Okay. You have a different one. This one I'm talking about. Do you have it? Are you going to get something from your calculator? Yeah. Matrix. Not use a calculator. Right? For you? So we are able to get the chi-square and the p-value. Everybody, right? For so far, if you have a calculator. Anybody having trouble? Because that's what we have to do. Enter the value into the matrix and use the chi-square test. So you have chi-square equal to 16.06 and the p-value is 0.011. Degree of freedom is 2 minus 1 times 4 minus 1. That is 1 times 3 equals to 3. That degree of freedom can be used to find the critical value as well if you want to use the table. If you want to use the table to find the critical value, you will have alpha here, degree of freedom, and here you have chi-square, which you will use and put it somewhere here. And then the chi-square value, like the 16, you compare it to this value to know whether it's to reject or not. But at this point, we know all how to use the p-value method, which we compare to alpha. P less than alpha, what do we do? If P is less than alpha, in this case, it's P less than alpha. Let's take alpha to be 0.05. It's less than alpha, so we reject H0. We reject H0. So what What does that mean? There is enough evidence to reject the claim that male and female at Teams College have the same preference when it comes to selecting a pet. So we reject the claim that male and females have the same preference. So these two tests are essentially the same. That is, test of independence and test of homogeneity. Now we want to test for goodness of fit. In testing for goodness of fit, we have two distributions that we want to show that they are the same. So we want to show that the new distribution is the same as the old one. Goodness of fit, 80. Population fit the distribution, the new population fit the distribution. H1 population does not fit the distribution. So K is the number of categories. Degree of freedom, here is K minus 1. Test value remain the same. I square equals to sum of observed minus expected divided by expected. So the difference with the goodness of fit test and the independence and homogeneity is that we are not going to use a matrix, but we are going to be able to compute the observed and the expected value and use it to calculate the test value. Let's look at an example. As here, the labor union bargaining agents listed 5 categories and asked each employee to mark them one most important to her or him. The categories are corresponding percentages of favorable responses are shown. So which one do you prefer at your work? Why did you choose this one? What was the most important motivation to decide to work here? People might say vacation time, some people's salary, some people the safety and regulations of the place of work, some people health and retirement benefits, some people the overtime policy and pay for overtime. So having that, this was what happened last year. You are a new manager in this facility, and you want to determine if new workers are still having the same distribution in their preferences. The observed value here will be what you collect. Observed value is always what you collect. So H0 will be the present distribution of responses is the same as last year. It is not the same. Let's look at the data that we have. On the first column, we have the observed values that you already know. Here is the observed value. Now we look at the expected value. Given that we have 500 samples, a sample of 500 individuals that we have, what would be the expected number? So it is observed that from their responses to the survey, that 30 of them prefer vacation. If the distribution was the same as last year, it should be 40% of 500. So the expected value is 4% of 500, which is 20. No, 290 say the preferred salary. Last year, 65% preferred salary. Of 500, if the distribution was to be the same, 65% of 500 will be 325, and so on. So we have observe an expected value. We will enter this into the calculator. L1, okay. Some of you may not have a calculator that has a goodness of fit test. So to check if you have goodness of fit test, just want to start. Roll down to see if you see goodness. Just doesn't have. Anyone else doesn't have? You all have goodness, you have goodness of fit? Goodness of it, yes. Chi-square goodness of it. Okay. So, if you have goodness of it, at first everybody should enter. If you don't have goodness of it, then enter L2 for observe and L3 for expected. If you have goodness of it, you can enter it anywhere because you will use goodness of it, so you can enter L1 for observe and L2 for expected. You understand? Because when you are using a calculator, then some of you will ask which line did you use for observe, which line did you use for expected. By default, it's L1 and L2. So you can enter L1 and L2. You enter L2 and L3. So you want your observe to be L2, observe, L2, expected, L3. Now, make L1 equals to L1 L2 squared. So if you are done, you go to start test chi-square test. Goodness of fit test, not chi-square. Goodness. Chi-square goodness of fit test. When you are done, let me know. So you enter on L1, observe, on L2, expected, and you go to goodness of fit test. Okay, that's good. You really know how to use your calculator. That is the most difficult part to show. So you can tap it twice. Good calculator. Yeah, yeah. Now, enter. Okay. That's what I mean by twice. And the sum of the x is our price. So you can see it here. Now, to find the p-value, we're going to find the probability that chi-square is greater than or equal to 14.15. So if you go to distribution to find the chi-square distribution, I don't know how it is written there. Maybe it's chi-square. Maybe it's like this chi-square CDF. It will be 14.15. And maybe put 10 million or 10,000. And the degree of freedom here will be what? K minus 1. We have 5 categories, minus 1 should be 4. So to get to this, like we were doing normal distribution, go to distribution and get down to chi-square distribution. What is your degree of freedom in your calculator? Anybody has what? Can somebody tell me what you have as degree of? Anybody has 4? You all have 5? You have 4? Anybody has 5? Why do you think they're having 5? I can explain, but I'm suspecting that you press enter at the end twice, I mean, a little bit more, and it gets to do that. So you can change it to 4. The degree of freedom is k minus 1. So sometimes you get 5. If you enter nothing, you will not use it, but you will take it as another category. And instead of 5, you will think about 6 and do 6 minus 1. And it will affect your p-value. What do you get? Do we have this as p-value? Okay, so if this is the p-value compared to 0.05, what could be our decision? What should be our decision? Do we reject or not? Compared to 0.05, that is 0.006. Is it less than, is p-value less than alpha? It's less than alpha, so we reject the null hypothesis. If we reject the null hypothesis, it means there is not enough evidence. There is enough evidence to reject the claim that the present workers have the same distribution of preference or motivation than the last year's workers. So you want to think about finding out what to do. Should you keep the same policy or should you change? This section, I have not been using it. So I'll quickly go over it. I think you have homework questions on it, I'm not sure. But it is not on the take-home problems because it's always difficult for me to cover everything. So I select some topics. This is one of the topics I don't usually do. But because we have the time, we still have about 25 minutes, I will quickly go over the test and confidence interval for the variance. What is more important is for comparing two variants, which I do. So we will save that one for Thursday. And 20 minutes will be enough for me to tell you what this is about. It's true that the difficulty here is because you don't choose table. 8.3. Testing and estimating the variance. So to test for the chi-square, we have H0 is sigma square is equal to A. H1 is sigma square is less than A for left tail. Sigma square is greater than A for right tail. Sigma square is different from A for two tail. The test value, we have done so many tests. That's the reason why I usually skip this. You can read it on your own. The test value here is chi-square equal to n minus 1 s squared over sigma square. Sigma square is the number that you have there. S is the sample standard deviation. S square is the sample variance. N is the sample size. That gives us the test value. So the little difficulty you have here is for the p-value. So I will put T here, as I said. For a left tail test, this is probability that I square is less than I square T. For a right tail test, the p-value, this is p-value. For a right tail test, P, I square is greater than I square T. That is the test value that you have here. And for a two-tail test is 2, P, I square is So the problem with a two-tailed test is that if chi-square is to the left, you double it. If it is to the right, or I'm going to put it this way, is either 2 chi-square t or 2 . Or you can use the critical value. By left tail, you have here, this is alpha, chi-square 1 minus alpha. For a right tail, chi-square alpha. Because this is alpha. If this is alpha, it's always a right tail test, then that right part of it is 1 minus alpha. And for a two tail, here is alpha over 2, here is alpha over 2. Chi square 1 minus alpha over 2. Chi square alpha over 2. So that's what I'm saying. It cannot be on both positions. It is either on this side or on that side. Whichever side it is, you just double it. So this is how you will, if you have the test value and the p-value, you can complete your test. Or if you have the test value and the critical value, you compare it to the critical value to make the decision whether it's in the rejection or not. Now, confidence interval. Confidence interval. The confidence level if the confidence level is C, take alpha equal to 1 minus C. Then we are going to have n minus 1 s squared chi square alpha less than or equals to sigma squared less than or equal to n minus 1 s squared chi square 1 minus alpha. That is the confidence interval or the variance. You can use the critical value method following this from Excel. You can use the critical value method from Excel. You can use the critical value from your calculator. See, this number is the area to the left. I'm sorry, this number is the area to the right. Excel is going to ask you, do you want chi-square right? Because test for the chi-square is generally right. What I'm saying is this. I don't want us to waste so much time on this. You can always come back to the PowerPoint if you want to learn about it. So to read the table for this chi-square left, chi-square right, as I showed you before, you go to a chi-square table. The number that you see here is generally up here. The degree of freedom is here. For this test, the degree of freedom is n minus 1. The degree of freedom is here. Alpha is here. It could be alpha over 2, 1 minus alpha, 1 minus alpha over 2. Whatever is the number which is here is what you read here to get the chi-square alpha. So we have the F test for two variances. Anybody too tired? Do you want us to just do 10.4? Anybody is eager to learn about comparing two variants? Anybody feel like going home now? Really? Is it because you don't like it or because you are just tired? Oh, okay, that's better. You can do homework on 10.1, 10. Really, 10.3, you can read it. I don't put it on the exam because I know it's but 10.4 will be on the exam. It's just not the test value there is S1 square over S2 square. So you can use your. I hope you are all good with the project. You are working on the project. Just work on the same group you were working on before. Okay. So we are good. So if you have any question, send me an email.